Welcome to Agentic AI World, interview prep for senior AI engineers. I'm your host, and today we're diving into episode 35. Today's topic, AI knowledge graphs, how senior engineers build, query, and integrate structured knowledge into production AI systems. If you're interviewing for a senior AI or ML engineering role, knowledge graphs are showing up more and more in system design rounds. Let's break this down the way you'd explain it in a real interview. Section 1. What is a knowledge graph and why does it matter? A knowledge graph is a structured representation of real-world entities and the relationships between them. Think of it as a graph database where nodes are things, people, products, companies, concepts, and edges are the relationships between them. The reason this matters in AI is simple. LLMs are great at language, but they're terrible at precise, structured facts. They hallucinate. They don't track relationships well. They can't tell you reliably that product A is manufactured by company B, which is headquartered in Germany, which has specific import regulations. A knowledge graph gives your AI system a source of structured truth, a place it can query for precise facts instead of guessing. In interviews, when asked, how would you improve factual accuracy in your AI system? Knowledge graphs are one of the most powerful answers you can give. Section 2. Core Architecture. How senior engineers build knowledge graphs. Let's walk through the architecture a senior engineer would design. First, you need an entity extraction layer. This takes raw text, documents, databases, web pages, and extracts entities and relationships. You'd typically use a fine-tuned NER model combined with a relation extraction model. Tools like SpaCy, Hugging Face Transformers, or specialized pipelines like Stanford CornLP are common here. Second, you need a graph storage layer. The two dominant choices are RDF triple stores like Apache Jena or Amazon Neptune, and property graph databases like Neo4j. For most production AI systems, Neo4j wins because it has a rich query language called Cypher that's intuitive and powerful. Third, you need a knowledge ingestion pipeline. This is where raw data gets transformed into graph triples, subject, predicate, object. For example, Einstein, born in Germany. You need deduplication logic here because the same entity might be mentioned hundreds of different ways across your corpus. Fourth, you need a query interface that your AI system can actually use. This is where most engineers underinvest. You need to translate natural language queries into graph queries automatically. This is where something like a text-to-Cypher model comes in, fine-tuned on your specific graph schema. Section 3. Integrating knowledge graphs with LLMs, the real engineering challenge. Here's where senior engineers shine in interviews. They understand the integration patterns. Pattern 1. Graph-Augmented RAG. Instead of just retrieving text chunks, you first query the knowledge graph for relevant entities and relationships, then combine those structured facts with your vector search results. Your LLM prompt now includes both retrieved text and precise structured facts. This dramatically reduces hallucination. Pattern 2. GraphRAG. This is Microsoft's approach, now open source. You pre-compute community summaries of your graph, essentially summarizing clusters of related entities. When a query comes in, you retrieve the relevant community summaries instead of just chunks. This gives much better global context. Pattern 3. Tool calling with graph queries. Your LLM agent has a tool that can run Cypher or SPERQL queries against the knowledge graph. The agent decides when it needs precise structured information, calls the tool, and incorporates the results. This is great for agentic systems that need to reason over structured enterprise data. Section 4. Common interview questions and how to answer them. Question. How would you keep a knowledge graph up to date? Answer. This is a graph maintenance problem. You need an event-driven pipeline. When source documents change, you re-extract entities and relationships, diff against existing graph data, and apply updates as transactions. You also need confidence scoring. Relationships extracted with low confidence get flagged for human review. In production, we typically version the graph so we can roll back if a bad batch of extractions corrupts relationships. Question. How do you handle conflicting facts in a knowledge graph? Answer. Great question. This is called knowledge-based completion and conflict resolution. You store provenance with every triple. Where did this fact come from? When was it extracted? What was the confidence score? When conflicts arise, you apply resolution rules. Prefer more recent sources, prefer authoritative sources, flag conflicts above a threshold for human review. Some teams use a separate LLM-based fact verification step. Question: what are the scaling challenges with knowledge graphs? Answer: 3 main ones. First, graph traversal at scale. Deep multi-hop queries get exponentially expensive. You solve this with query optimization, graph partitioning, and caching hot subgraphs. Second, write throughput during ingestion. Batch updates and transactions. Use write-ahead logging. Consider separate read and write replicas. Third, schema evolution. As your domain grows, your graph schema changes. Use version schemas and migration scripts, just like you would with a relational database. Section 5. Production patterns and hard-won lessons. Let me share the patterns that separate good from great in production knowledge graph systems. Lesson 1. Start with a narrow schema. Don't try to model everything. Pick the 3 or 4 entity types and relationships that matter most for your use case. You can always expand later. Teams that start broad end up with unmaintainable graphs with thousands of poorly defined relationship types. Lesson 2. Invest in your entity resolution layer. Duplicate entities are the silent killer of knowledge graph quality. Apple Inc., Apple, and Apple Computer are all the same entity. Your deduplication and entity linking logic needs to be robust before you ingest at scale. Lesson 3. Build evaluation pipelines from day one. You need to measure graph coverage. What percentage of facts in your domain are captured? And graph accuracy. What percentage of captured facts are correct? Without these metrics, you're flying blind. Lesson 4. Human in the loop for edge cases. Never rely purely on automated extraction for high-stakes facts. Have a review queue for low-confidence extractions, especially for relationships in regulated domains like healthcare, finance, or legal. Section 6. The senior engineer's mental model. Here's the framing that will make you stand out in any interview about knowledge graphs. Think of your AI system as having 3 memory types. Parametric memory, what the LLM learned during training, baked into its weights. Episodic memory, retrieve context from vector stores, recent conversation history. And semantic memory, precise structured facts from your knowledge graph. Each type has different strengths. Parametric memory is great for reasoning and language. Episodic memory is great for recent and domain-specific text. Semantic memory is great for precise facts, relationships, and structured queries. The best production AI systems use all 3. The knowledge graph is your semantic memory layer, your system's source of structured truth. When an interviewer asks how you'd improve factual accuracy, reduce hallucination, or handle complex multi-hop reasoning, the knowledge graph combined with vector RAG is your power answer. Section 7. Quick-fire interview answers. What database would you use for a knowledge graph? Neo4j for most cases, mature, great Cypher query language, strong Python integration. Amazon Neptune if you're all in on AWS and need managed infrastructure. RDF triple stores if you need W3C standards compliance. What's a triple store? A database optimized for storing RDF triples, subject, predicate, object. Every fact is broken down into this atomic 3-part structure. What is ontology in the context of knowledge graphs? The schema, the formal definition of entity types, relationship types, and the rules governing them. Think of it as your graphs type system. What's the difference between a knowledge graph and a property graph? A knowledge graph typically implies semantic meaning and ontological structure, often using RDF or OWL standards. A property graph, like a Neo4j, is more flexible. Nodes and edges can have arbitrary properties. In practice, many production systems use property graphs and call them knowledge graphs because the term has become more generic. That's a wrap on episode 35. Knowledge graphs are a force multiplier for any AI system that needs precise, structured reasoning. Master the architecture, the integration patterns, and the scaling challenges, and you'll stand out in any senior AI engineering interview. If this was useful, subscribe to Agentic AI World for daily interview prep. We drop 1 episode every day covering the deep system design and engineering topics that actually come up in senior AI interviews. See you tomorrow.